Hello everybody. I won't say good morning since I suspect some of you are listening in from other time zones. Thanks for coming along. My name is Michelle Carey. I'm the Head of Product Development here at IMDEX, and the topic that I'm going to be talking about in the webinar today is drill hole planning, how technology can help you optimise drilling right from the start. In terms of how we're going to run the webinar today, I have James here acting as moderator for me. If you want to type questions as we go along, please do so. James will answer anything simple and will certainly flag to me if we're having audio or visual problems, but otherwise we'll tackle questions at the end. But as I said, please don't hesitate to raise them as they come to you. We'll keep an eye on them. Okay, so diving in. Okay, before we talk about our topic for today, one of the things I like to make sure is that everyone knows who IMDEX are. We quite often find that people may know who IMDEX is, but they almost always, if they don't, know who our brands are. So we have two key brands that people see out and about on the marketplace, and particularly at drill sites all the time. AMC is its key branding is around drilling optimisation, and of course traditionally a large part of the AMC business and brand has been drilling fluids, and many of you will have seen our green and yellow buckets out on a drill site. And then on the other side, Reflex, traditionally the core of the business under this brand has been survey tools and core orientation tools, and again I'm sure many of you have seen our brand out on rigs around the world. Increasingly though, across both of those brands, we have a much larger array of sensors and software solutions, and you'll see a lot of those as we go along in this morning's presentation. Okay, so another theme that I really wanted to flag before we dived into this is I'll be talking a little from the geoscientist perspective today, but it's really important that nothing that I talk about is just for the geoscientists. We're very much about win-win solutions and win-win relationships between drillers and resource companies. And when we design a solution, that's very much the angles that we take, is how do we make sure that this solution is easy to use and improves productivity for both drillers and resource companies, but also provides to geologists the data that they need to make decisions and to plan and execute their drilling programs well. And obviously IMDEX Hub IQ, as almost the data broker between those two groups, is a really key part of what we do within that win-win solutions for both space. Okay, so this idea of drilling optimisation and optimising the way that you actually explore all the way from the planning step, we like to think about that as a cycle of activity. It starts with planning, and really that will be a big focus of what I talk about today. And then obviously you actually need to go and drill the hole, and I will talk a little bit about new drilling technologies and how that space is changing. And then there's very much that monitoring piece, is after you've planned, how do you monitor to make sure that what you're doing is going to plan? How do you monitor to make sure that you don't need to change that plan? And of course, most important of all is this is all about decision making. It's not about providing more and more data. It's about enabling a process that allows you to decide, make good decisions about what you want to do. Okay, so let's talk a little about the sorts of choices that you can make right up at the highest level at the planning stage. A really big one is brutally, how much can you afford? What's the budget that you've been given for this drilling program? How many meters can you drill as a result? But it's not actually the only consideration, and it may not in the end be what's most important to you. Maybe risk of hole completion is actually more important to you than cost. Maybe you know that you have to hit the target no matter what, and you're willing to spend more money in order to achieve that. Maybe you've got really strict environmental regulations where you're trying to drill that mean you actually have to take a significant amount of consideration of the environment, and that in some ways controls what you do rather than it being strict, do this for the minimal amount of money. And then, of course, you know, almost the unsaid but acknowledged challenge is, do you even have enough data to control costs? Have you got the ability to say, this is what's costing me so much money with this program, here's what I'm going to do to change it? Do you even know as you go along how much the program's costing you and when you're going to run out of budget? It's very much that if you don't monitor it, then how can you manage it type concept. So thinking then, I guess, of the next level of decisions down, you've thought about what it is that's going to control the way you put your program together. Then you start asking yourself questions about, how do you want to drill the hole? Again, you know, how much am I going to be spending? Is speed important to me? Do I have a short field season where I have to get everything done? What depth am I going to drill to, and how does that constrain the method that I use? You know, cost might be important, but you might need to get to such depth that you have to diamond drill. It's all those pros and cons. And then again, how do you want to drill the hole? Another question is, what fluids do you want to use? Now, as geoscientists, this isn't something that we've traditionally necessarily thought about. We just say to the drillers, yep, off you go, drill the hole, and they come up with a fluid program. But they will just come up with potentially just their generic normal approach. What about what you have the ability to say, in this instance, I really care about core recovery. What can you do with the fluid program to increase the amount of core that comes out of the ground? Hole stability so that I can hit target is incredibly important to me. What can you do to improve and adjust the fluid program to optimize that outcome for me? Those are things that can be done, can be optimized. As geologists, we just need to know to ask. And then where do you want the hole to go? You might not, you know, increasingly as we go to depth, and we're going to talk about this a bit more, you might actually need to do directional drilling to get to your target. That requires a significantly increased amount of planning if that's the outcome that you're aiming for. And then what decisions are you going to make as you're drilling the hole? Do you need to be able to stop and start the hole in real time? Do you need really tight control on where the hole's going? These sorts of questions allow you to think about what sort of sensors you're going to deploy onto your drilling program. So we'll step through now and talk about each of these aspects in a little bit more detail. Okay, so thinking now about some of those macro considerations around cost control. And the first, these statistics come from the ABS, and they illustrate what the expenditure has been on exploration against the meters drilled. And what you can clearly see is that about 12 years ago, it started getting more and more expensive to drill the same number of meters. Now, lots of factors that contribute into that. And you can see here over the last few years during the downturn, a little bit of that got clawed back. We were able to negotiate with drilling companies for them to drop their rates. But the brutal reality is that drop was not particularly sustainable. The drillers are not really running sustainable businesses at those rates at this point. And so I suspect you'll see that red line starting to creep back up again. So this means it's increasingly important for us to be able to control and optimize what we're doing, because our exploration success is tied to the amount of meters that we drill. It's the truth machine, right? If we're not drilling holes, we're not finding anything. And the other macro consideration here is one of the reasons that drilling is becoming increasingly expensive is because we're having to drill deeper and deeper holes. And it's not a linear thing, as we all know. As we go deeper, costs don't go up in a linear way. They go up much more than that. This is a Richard Shoddy chart, obviously the source for all exploration statistics these days, really just illustrating that the deposits that we're discovering are indeed becoming deeper and deeper as we're forced to go undercover. And again, I think that this is a trend that we're only going to see continue. The consequences of this are, you know, more challenging drilling, likely more directional drilling as we have to try and aim for targets deep under the ground. Okay, so thinking now about cost control and how IMDEX technology can help to optimize drilling and therefore reduce costs. These are some industry averages around the way a drilling crew divides its time. And again, this is a brutal but known fact, is the reality is that a drilling crew doesn't spend as much time as we would like actually drilling with bit on bottom. So you can see here the industry average that we're stating here is 40%. People can argue that it might be a little higher than that, but really that's a dauntingly low number. And all of these other activities are generally time that we would like people to be spending with the bit on bottom. So what we've then done as IMDEX is to say, well, which of our technologies, how is it that we're starting to improve that? How are we improving productivity by starting to reduce some of these non-drilling activities? We'll talk about all of these in a little more detail, but I'll just touch on a couple of them now. An example here, if you're in a situation where you have to cart water from a long way away in particular, and you're losing a lot of time, then having an SRU on site, solids removal unit, which allows you to recirculate drilling fluids and not have a sump in place, means that you can reduce the amount of time you have waiting for water so that you can increase the amount of time drilling. Something simple like the amount of time lost to survey a hole. Now, obviously, how long this is depends on whether the drillers are doing it or whether a service provider is doing it for you. But either way, with new technology now, with continuous gyro survey tools, you can run these surveys incredibly rapidly and really minimise the amount of downtime for surveying. And then down here we have things like fluid composition, the SRU and the BOSS tool being used to optimise the condition of the hole. So you have to spend less time in hole conditioning, less time tripping the rods in and out, again enabling you to spend more time with bit on bottom. And this is really just illustrating that same thing in a pretty graph. You know, it's pretty compelling. If you chip away at each of these little things, then cumulatively you can get a very significant improvement on that bit on bottom time. So it doesn't have to be rocket science, right? It's just doing things well, optimising your drilling at the start. And really just to return to this point about knowing your fluid program and making sure that you work with your drillers or indeed work with a mud engineer to make sure that you've optimised the way you drill to consider the fluid program. As I said, really there's all sorts of things that you can optimise for. You can optimise for core recovery. You can optimise for the stability of the hole. There are environmental considerations which might impact the sorts of fluids that you choose. We'll come back and touch on how you can then monitor to make sure that whatever it is that you've agreed you want to do is actually happening. But this planning step up front of considering what you're optimising for is really critical. And it's not just about fluids these days. There are all sorts of innovative ways you can actually deliver that fluid. So rather than mixing it up in green and yellow buckets on the surface, it might be preferable to inject it at the point of drilling. In particular, we use the AMC BOSS tool to inject a product that we call BOSS Fix. And what it enables you to do is to keep the hole stable and prevent the loss of fluid as you're drilling. So this is particularly important if you've got ground conditions where you know you're going to have really significant fluid loss. So normally the approach to having to deal with that would be you pulling the rods out, grouting the hole, drilling back through to go, and obviously that's really unproductive. If you use the BOSS and BOSS Fix system, you can be injecting BOSS Fix as you go, keep the hole stable, no tripping rods, just keep drilling. And in the SRU, we've already touched a bit on how you can use this to improve productivity and reduce costs. But down the bottom there, those bottom three, I really wanted to flag some of the environmental considerations as well. So obviously, if you are recirculating your fluid using a centrifuge and tank system, then you don't need to build sumps in the ground. You don't need big holes in the ground anymore. Obvious safety considerations, but obviously it also reduces the amount of environmental disturbance, reduces the footprint of the site, and also reduces the amount of water that you're actually using. So for sites where environmental restrictions and minimising your footprint are really important, we increasingly see resource companies turning to SRUs to give them those outcomes. Okay, so really though, that section there was just talking about using the here and now technologies, thinking about how you use them well so that you can optimize productivity and keep the costs of your drilling program down. The next few slides I want to talk about are some innovative new drilling technologies that IMDEX is about to introduce to the market over the coming 6 to 12 months. Now, one of them isn't coil tube drilling, if anybody on the call is hoping that that's something that I'm going to be talking about today. Now, obviously, we were involved with the DET CRC project, and we're now involved within the MinEx CRC, where coil tube drilling is a key research platform. But really, we think that technology is still a few years away at best. And so these sorts of technologies that I'm talking about now are about how you can take conventional drilling and take it to the next level. So the first of these technologies is CoreVibe, which is an enhancement to diamond drilling. So it can actually be used with any conventional diamond rig, and what it does is it's a wireline tool that you put down to replace your existing diamond drilling, and what it does is that it incorporates a vibration action, which is from a fluid-driven swash plate, which means that at the same time as your diamond drilling, you also have a vibration aspect. What does that do? Well, it increases your penetration rate by up to 50%, which leads to productivity increases of up to 33%. You can see there in big and bold that those are audited results. We have a test site, a research facility in New Zealand, where we have a number of drill rigs operating, testing these technologies. And we had an external auditor actually go out to that site and review the results we were achieving, and that's the numbers that you see there. And what does that mean? If you think about what that means compared to traditional drilling, well, you can see here, if you're drilling quite a deep hole, a couple of kilometre hole in this instance, then you go from that taking you 67 shifts to do to 47. So, you know, really you can start seeing what the knock-on effects of that productivity benefit would be. And there's also obviously some other incremental improvements that come with that vibration that occurs during drilling. One of them is that actually it seems like it extends bit life, because the vibration means you're clearing particles away from the face whilst you're drilling. And it also, we think that it reduces the need for tripping, because you see less blockages of the inner tube, so less core blockages, again, probably because of that vibration action. So we've been working with a company called FlexiDrill on these technologies in partnership. You can see the details of the way that has been structured. It's actually been publicly announced. We are hoping to go to our first commercial trials of this technology over the next couple of months. And so you should start seeing this technology out in limited release over the next few months. So very exciting times. And then the next wave of technology behind that, and this one's a little bit further away, we'd be expecting, we're still in the research phase, but we're hoping to be doing the first commercial trials towards the back half of this year, is a technology that is called MagHAMMER. And so what this is actually a fluid-driven RC type drilling approach, but you can actually use it with a conventional diamond drill rig. So it's a combination of coring and hammering drilling occurring at the same time. But because it's fluid driven, you can actually eliminate the requirement for high pressure air. So obviously I'll talk a little bit about productivity benefits in a moment, but it also means that all of a sudden you don't need a compressor on site. You don't have all of the safety risks associated around having those large compressors and having all of the dust that rigs like that can generate if you don't have appropriate fluid control. And also because you can use it with your current diamond rig, you have to deploy a lot less capex to site, so you can see a lot of cost benefits. Now, one thing that I'll mention here is that in its initial applications, our intention is to put it out just to drill pre-collars where there isn't a sampling requirement. But obviously the future of this technology will include being able to sample in a manner similar to RC. Obviously it is a fluid-driven system, so the sampling requirement will be a little different, and it is a combination of diamond and coring, so the particle diamond coring and hammering, so the particle size distribution is a little bit different to what you get in RC. But due to the work that we've done within the DET CRC, we're actually quite well advanced in developing the sorts of sampling systems that a MagHAMMER would require in order to do proper representative sampling. So again, if we look at MagHAMMER compared to traditional RC drilling, you know, you can see the very artistic depiction of a site where you need to have a compressor and potentially you have dust control challenges. You turn that around. Instead, you're using your same diamond rig. You've just placed a MagHAMMER on it. You can drill at the same sorts of rates as conventional RC drilling, but with the exciting addition that it doesn't have the same restrictions about hitting the water table. Obviously, because it's not using compressed air, it's using fluid in the first place. You can continue to drill through the water table to significantly larger depths, still with the sorts of penetration rates that we're used to from RC drilling. And I think we can all imagine the productivity benefits that flow from that. Okay, so at the start, when I was talking about macro trends, one of the things that I mentioned was this increasing trend towards deeper drilling and likely directional drilling to hit deeper targets. So what does that mean? Well, certainly at the planning stage, it means that you need to put quite a bit of consideration into how you're going to get the hole to where you want it to be. And you need to do that from two different perspectives. You need to consider from a geologist perspective what it is you want to hit, and then from the driller's perspective, how are you going to get there. And if we look at the slide that I have up now, on the left, I'm actually using geoscience analyst to illustrate how geologists are increasingly doing that drill hole planning step, which is to sit within their normal rich 3D environment and identify the target that they want to hit, and then a collar position that enables them to get to that hole. So that's kind of the geologist's part in this, this process. And then you need to hand that over to a driller and say, well, here's where I want the hole to get to. You tell me how to achieve that. You tell me what sort of build rates and therefore what sorts of cut points are possible. You tell me where I need to start navigational drilling. And obviously what you'd be hoping for is that the driller does that for you in a way that minimises your cost but maximises your chance of actually hitting the target. And the software that I'm showing there is EasyNav, which is a piece of software that we supply to drilling companies to enable them to plan their drilling in that fashion. And really the other thing, and I'll touch on this again when I come to the monitoring piece, is this is not a one-off set and forget type planning process. This is iterative. No plan survives the first contact with the enemy. So it's highly probable that as survey information comes in telling you where your hole's gone, that this plan will need to be revisited and adjusted to make sure that the hole really does hit the target that you're aiming for. And then of course, once you've planned, it's about, well, here's the trajectory of the hole, but what technology am I going to use to get there? On the left there, you can see a downhole motor. Am I going to use a downhole motor to do this? On the right, you can see a wedging system. In some parts of the world, that's still the prevalent approach to trying to deviate holes and hit a target. There are some service companies out there that provide a full service that includes directional core barrels to complete directional drilling. These are the sorts of options you need to consider when you're planning how you're going to get to your target. Okay, and then the next planning decision, and again this is still very much at the planning stage, is what are you going to monitor? And I really would like to emphasize that this should be a decision and not a default. This shouldn't be the driller saying, yeah, this is the survey tool and this is the core orientation tool that I always use. This should be a very conscious decision about what is it as a geoscientist that I want? What's the quality of the data that I require? What's the accuracy that I require? What are the key considerations that are going to allow me to pick my sensor set correctly? And the first of those decisions comes down to how am I going to line up the drill rig in the first place? Now, it's still common in a lot of applications on the surface for a geologist to go and line up the rig with a compass and some flagging tape and a few pegs. And there are certainly plenty of applications where that's still appropriate. But for a for a high cost drill hole, for one where you're really, it's extremely important that you start the hole right so that you hit your target, you might want to consider using a rig alignment system to do that initial setup step. The picture there is of our TN14, which is our optic gyro-based rig alignment system, which is extremely accurate and also has the advantage that as a geologist, you can push down to the driller exactly the coordinates that you want to line the rig up against. And we use IMDEX Hub IQ to give you a chain of custody to illustrate that the driller really did line the rig up the way that you asked for it to be lined up. So really controlling, making sure that the rig has been set up at the start for success. And then, you know, a question that we're all relatively used to asking ourselves is, what survey tool do I actually need? And again, you know, a fairly normal question for us is, well, do I have non-magnetic ground? Can I use something like the Easy Track, which is an accurate but cost-effective way of surveying my hole? Or am I in a situation where I'm RC drilling or I have magnetic ground conditions and so I need to move to a gyro? And we certainly see within the market now, with north-seeking driller-operable gyros becoming more prevalent, that increasingly the resource industry is turning to using gyros as their default surveying technology rather than magnetic tools. And then you can take that one step further now, because we don't just have driller-operable gyros, we can deploy those gyros in all sorts of different ways. So the question for us is, well, what's the data that you need? What's important to you? Therefore, which gyro should you use? Over on the left, you can see the path from a continuous north-seeking gyro tool, our Sprint IQ. Now, obviously, you might want to pick this tool if speed of survey is really important to you, but if you also want a continuous survey run to give you an idea of where the hole is at, you know, meter frequency all the way up and down. And then you heard me say up and down. One of the other joys of using a continuous tool that can be run very rapidly is you get to do an in and an out run and complete QA that way as well. So you really get to have very high quality data by using the Sprint tool or any one of these continuous tools. And then in the middle here, you can see I'm showing a rotor lock. So the rotor lock system allows you to deploy a north-seeking gyro as part of the process of going down and retrieving the core barrel in diamond drilling. So particularly, you can imagine if you're doing deep diamond drilling to hit a target, a really efficient way of getting survey information every 6 meters is if you can get a shot whilst you're retrieving the core barrel. So you're not losing any time to the drilling process at all, really, but you're able to get a really accurate and closely spaced path of where the drill hole's going, so that you can help guide some of those decisions around directional drilling and what you want to do. And then on the far right is something that is, you know, commonplace within oil and gas, but increasingly a possibility within the mining industry as well, which is this idea of coupling sensors together. So why just get a survey tool run up and down the hole? Why not add another sensor? In this case, our natural gamma probe, the Easy Gamma, so that you can get some petrophysical data at the same time as surveying your hole. So no productivity hit at all, but an extra data set. It's pretty compelling. And then the next sensor consideration is really about, well, a lot of us will orient our drill core, but how many of us really do it as a conscious thought to say, I'm going to be collecting structural data as part of this drilling program, and it's incredibly important to me. So I'm really going to make sure that the core orientation tool is the best on market, and that my drillers are using it correctly. And really the pictures here are just to remind us all of something that we know very well, which is the criticality of survey data, of core orientation data and structural data, in making sure that we know where our ore deposit is going, and indeed how we design our mine to recover that resource from the ground. And then, you know, you can sort of see that the sorts of decisions that we're considering here keep stepping up a level in terms of complexity. So I've been talking a little bit about making sure that you have data you can trust. I've spoken a bit about making sure you have the right survey tool so that you can monitor the direction of your hole and change it if you need to. But there are other decisions that a geologist might need to make at the rig or away from the rig in real time. And those are these decisions about, do I stop the hole because we've already gone through mineralisation, or actually it's pretty clear now that we're not going to go through mineralisation in this drill hole? Do I need to keep drilling this hole because the signs are good that if I continue on, I'm going to hit something? And then the next level of decision on again, now that I've drilled this hole, should I drill the next one? And really this is the next level up of drilling optimisation, making sure you only drill the meters that you need to, not wasted meters. And there are, you know, and this is really about this putting sensors on a rig that allow you to make real-time decisions rather than just trusting your own visual observations. And just again, looking at this from a value perspective or a cost perspective, we did, within the DET CRC 3 or 4 years ago, we were heavily involved and indeed commercialised a piece of technology called Lab at Rig, which is all about getting real-time top-of-hole geochemical information from diamond drilling. But what we did is we actually worked with Deloitte to evaluate what the value proposition around a technology like that. What's the value proposition around having real-time information that allows you to make better decisions about stopping a hole, not drilling another hole, really, you know, maximising your efficiency and minimising your meters drilled. And it was really interesting, you know, we went through this piece of work with Deloitte, and they looked at it holistically to say, well, what are all the areas where you might potentially save money using one of these real technologies? They thought about the things that we tended to get asked most often, which are, well, obviously this is all about cutting laboratory costs. And really what it showed is what if you think about it intuitively, you know is to be true, is that those aren't the important things at all. The important things are this concept of, well, if I can make better decisions in real time, I can reduce the amount of meters that I drill. And this just shows that graphically. You know, the work with Deloitte suggested that these sorts of real-time technologies might allow you to save between 15 to 20% of the cost of any given drilling campaign, and that yes, a little bit of that comes down from reducing your lab bill, but a really big chunk of it, up here, 13% of it, is reducing the number of holes that you drill, reducing the average depth of a drill hole. Okay, so we've planned our program, we've picked the most optimal drilling technology, we've designed a fluid program that works. How do we monitor to see whether our plan is coming to fruition? How do we monitor to make sure that if we need to make changes, we know what they are and we can action them effectively? So talking first again about cost and productivity and how we monitor those. This is our IMDEX mobile solution. We've had this in the market for 4 or 5 years now, and it's close to an industry standard with about 40 or 50,000 forms a month coming through. And all it does, in some ways it's very simple, it just replaces the paper systems that people used to use to capture their plods or daily drill reports with a digital system with a database behind it, and most importantly a reporting engine behind it, so that you can turn that data into actionable information straight away. And this just shows you the sorts of things that allows you to monitor on a day-by-day, shift-by-shift, week-by-week, month-by-month basis. You saw at the start me presented some graphs about how IMDEX technology improves drilling productivity. Of course, there are other things that you can do as well, and really one of the keys to you doing something to improve productivity is to see where your problems lie in the first place. So you can see here, this pie chart shows you rig activity versus cost. So you can start identifying which areas are there here that are costing you money, that are not drilling, that are not bid on bottom time. Which are the areas where you need to focus your efforts so that you can improve productivity? And then, of course, as well as monitoring productivity, we actually enable you to monitor cost directly. You can actually, at the end of each day, if you want to, run a report that tells you this is how much drilling costs me today, which allows you to say, well, my budget was, you know, $2 million. Holy cow, it looks like I've already spent 30% of that and I've only drilled 10% of my program. So it allows you to start, you know, to actually control your budget because you can see what's going on. Okay, so what else can we monitor? Well, I spoke a little around the importance of designing an optimal fluid program for your drill hole. The great news is now that you can monitor that as well. So this is our MUD AID system. What is it? Well, it's a series of sensors that you put out on a drill rig that continuously monitor the chemistry and the properties of that fluid. What does it mean? Well, it means that if your fluid program falls out of spec, then somebody who's not on site, somebody off site, can actually see that straight away and can do something about it. So they can actually ring up the driller and say, hey, something's gone wrong. You need to adjust your fluid properties so that you maintain optimal drilling conditions. And like a lot of our technologies, MUD AID is hooked up to IMDEX Hub IQ, so this information is actually available to geologists as well. So we can actually, and this is something that's never been available to us before, we can see whether the fluid program that was designed for us actually has been being used. Has it been being used all the time? And you can start linking it up to productivity information so that you can see when were the times where it wasn't used and what impact did that have. So, you know, I think that really gives us a higher degree of visibility and control than we've never had before. And then the next consideration around monitoring is monitoring to make sure the quality of the data that you're receiving is good enough for you to make decisions on. Are you being given data that you can trust? This slide just illustrates an approval process for one of our survey tools, our magnetic survey tool actually, but we have this for most of our instrumentation, and the idea is, as I say, just to provide drillers and resource companies with that first level of monitoring information. Is this information fit for purpose? Has something gone wrong with the tool or with the operation of the tool that I need to know about? Then the next level, and the cooler level of monitoring, I guess, is what does this actually mean? So this is what drill hole monitoring in terms of survey data can look like now. So we've worked in partnership with Sequent to allow data to flow from our survey tools through IMDEX Hub IQ and up into their central platform. What does that mean? It means you can monitor the trajectory of your drill hole in real time within a 3D environment and make sure that that premise that I've been talking about, that are you going to hit your target, you can actually monitor that in 3D in real time. And of course, what that also enables is if you're not going to hit your target, then you can talk to the driller and see whether they can modify the drill hole plan to change that so that you can actually get the benefit of that drill hole. And then, so for core orientation, we have that same level of monitoring the quality of your data. So this is our ActIQ system, which you can use with existing ACT tools as well, which enables on both a tablet within IMDEX Hub IQ for the driller and the geologist to check and make sure, is my core orientation reliable? Has the tool been used correctly? Is the tool operating properly? Has the mark that's been put on the core, is it going to allow me to collect accurate structural data? And then again, the next level of monitoring up is when you then go ahead and collect structural data, in this case using the IQ logger, then that data also flows through into the Sequence Central platform so that you can look at those structures in real time in 3D and again say in Monitor, does this make sense? Do these structures do what I think that they were going to do? Does this mean that my drill hole is going to hit the target, or have I just identified something in the structural information that means even though the hole's on track, the structure has moved the mineralisation to somewhere else? And then really just rounding this out is what other, this concept of using other sensors other than just geologist visual observations to understand rock properties in real time and make those decisions about stopping holes and continuing holes. Down the left-hand side there, you can see I'm illustrating some different ways that you can do that right now. You could use a petrophysical probe, that's our easy gamma, that can give you some really critical information about rock properties that you could use. I've put our in-field geoanalysis kit there. That allows you to prepare samples in the field, RC chips, for example, or air core chips in the field, to crush them down and turn them into a fine-grained puck that allows you to use an XRF to get really high-quality geochemical data in close to real time, which again you can use to make some of those decisions about stopping holes and drilling whether or not you drill the next one. And down the bottom there, a bit of a plug, I guess, for Mineralise, who we've been working in partnership with. For them, they now create gas files off of the back of their technology, which allow you to then start interpreting the sorts of data you collect off that system in near real time. And of course, that's what you can see over on the right there. That's IOGAS, our desktop analytics platform. And really, that's just that reminder that this is the end goal here. It's not about planning a program to create lots of data. It's not about monitoring so that you can see how much data you generate. All of this is about making sure you've got data so you can turn it into information so that you can make decisions. And of course, the IOGAS analytics piece helps in that data into information progression. And that's it for today. I'd like to thank you all for your time. Now I'm just going to turn to James and ask if he has any questions for me. So the question that I've been asked is how to find out the composition of the fluid, and in particular in relation to XRF. And I assume that's more a question of you making sure that there's nothing in your fluid that might affect the XRF data. So MUD AID, which I touched on a bit, gives some fluid parameters, but probably the broader answer is lots of fluids is this is something you should think about at the planning stage. Lots of fluids are organics only and won't affect the composition of your sample anyway. The sort of things that you most need to look out for are greases. Quite often if things got moly in its name, for example, you'll find out that's actually because it's a grease that's got quite a lot of molybdenum in it. So this is really something that you can ask a mud engineer about, and they'll tell you. And if you've got particular concerns about a particular metal, they'll make sure you don't use that fluid. Okay, that's good. No other questions? I think I need more coffee now, to be honest. It's just gone 9 o'clock, or just about to go 9 o'clock here in Perth, and still quite early in my day. I'd just like to thank everybody for listening in today. We really appreciate the opportunity to share with you some of the things that we're looking to do to optimise the drilling and planning processes. If you think of any questions subsequent to us finishing up this morning, please don't hesitate to send them through. We're more than happy to help you out. Thanks you all again.